going to take a look at solving systems of linear and quadratic equations by substitutions. So remember, linear, that's when we have a line when we graph, and a quadratic is the parabolas that we've been working on. So when we're looking at solving a system of linear and quadratic equations, we're trying to see where they intersect. So for example, we could have a parabola that goes like this, and then we can have a line that goes through here. So in this case, we would have two solutions, okay? And then we have another case where we could have a parabola that opens down, for example, and then a line that hits, let's just say, right at this perfect spot, and so that is one solution. And then the last case is if you have a parabola and a line, and it never intersects. Okay, so that would be no real solutions. So what we're trying to do is we're trying to solve for these systems, but we're going to solve by substitution, right? Solving a system by substitution. Remember, substitution means to replace. So let's check out this example. Solve the system by substitution. We have y equals x squared plus x minus 1, and y equals negative 2x plus 3. So equation 1, that is our quadratic, right? Quadratics always have a squared value, and linear has the x raised to the first power. So what we're going to do is we see that we have y equals and y equals. Okay, y equals x squared plus x minus 1, and y equals negative 2x plus 3. So what we can do is set these equations equal to each other, because y does equal y, right? We know that that is true. So because that is true, we can go ahead and write the equation. So for equation 1, we have x squared plus x minus 1, and that equals equation 2, which is negative 2x plus 3. Now we're going to set it equal to 0, so just remembering how to solve. So we're going to add 2x to both sides, so that cancels that out, and then subtract 3 also from both sides. Okay, so we're just moving everything to set it equal to 0. So now we have nothing here, so this is now x squared, and then 2 plus 1 is 3x, and negative 1 minus 3 is negative 4, and that equals 0. So we have x squared plus 3x minus 4. Now, of course, we go through all the checkpoints. Is factorable? Can we solve by square roots and so forth? So I do notice that this is factorable because negative 4, something multiplies to negative 4 that adds to 3. And so what that value is we have to have a negative. So we have 4 times negative 1, right? 4 times negative 1 is negative 4, and 4 minus 1 is a positive 3. So this factors to x plus 4, and then x minus 1 equals 0. Then using zero product property, we know that x equals negative 4 and x equals 1. Now, we found our x values, right? But we need to figure out what our y values are, right, when solving for a system. So it's a little different because we have two x values. So what we want to do is we want to take these values and go ahead and substitute it back into equation 2. You just pick the one that's nicer, and I would prefer to do equation 2 because it's only linear. You could do it in equation 1, but it's a little more work involved in that one. So let's go ahead and plug it into equation 2. So equation 2 is negative 2x plus 3, and let's plug in negative 4, right? We're plugging in negative 4 into this. So negative 2 times negative 4 plus 3, that is positive 8 plus 3, or that is 8 plus 3 is 11. So one of our ordered pairs that we have is negative 4 comma 11, right? That's where it intersects. So now we have x equals 1, and again we're going to plug that in into equation 2. So we're going to say negative 2 times positive 1 plus 3. And so negative 2 times 1 is negative 2 plus 3. So negative 2 plus 3 is 1. So now our other ordered pair that they intersect at is 1 comma 1. Okay, so if we were to graph these equations, x squared plus x minus 1 and negative 2x plus 3, they would hit at these two spots. Okay, so that's what it means. So let me do one more example. Let's take a look at y equals negative 3x squared plus 2x plus 1, and y equals 5 minus 3x. So again, because you have y equals and y equals, we can go ahead and set the equations equal to each other. So we will write negative 3x squared plus 2x plus 1, and that equals equation 2, which is 5 minus 3x. So let's go ahead and put the constants together. So I'm going to subtract 5 and put it with the constant, and we're going to add 3x to both sides, and we'll put that with the one with the x value, right? Combine like terms. So now we're left with negative 3x squared, and then let me write it together. We have negative 3x squared plus 2 plus 3 is 5x, and 1 minus 5 is negative 4, and that equals 0. So we have negative 3 times negative 4. What I like to do is I like to have my my x squared value positive. So what I'm going to do is I'm going to multiply by a negative in order to change it, or you could change sides by adding. So I'm going to change it to positive 3x squared, and this becomes negative 5x. This becomes a positive 4 equals 0. So let's see if this is factorable. Are there any factors of 12 that add to negative 5? So we have 4 times 3, 6 times 2. And so what I'm seeing is that it is not factorable, right? 4 times 3 is 12, 6 times 2, nope. So what I want to do is let's go ahead and use the quadratic formula, okay? So not factorable, so we have to use a quadratic formula. So let's see. A is 3, B is negative 5, and C is positive 4. So we plug it in to our quadratic formula. So x equals negative 5 plus or minus the square root of negative 5 squared minus 4 times 3 times 4, and then all over 2 times 3. So now we have negative 5 is a positive 5 plus or minus the square root of negative 5 squared is positive 25. 4 times 3 is 12 times 4, so that is a negative 48. All over 2 times 3, which is 6. So now what I see is x equals 5 plus or minus the square root of, so we have to subtract 48 and 25. So that is negative 23. Negative 23. Now, if you remember when we're doing the quadratic formula, and we're using it before, if we ever get a negative inside the square root, this means that there is no real solutions. Okay, so if you're solving for a quadratic and you get a negative in the center inside the square root, that we call it the discriminant, then that means it's no real solutions. So in essence, whenever you do this, you can either get 2 real solutions, no real solutions, or which means they never intersect, and 2 they intersect in 2 spots, or like I mentioned earlier, you could get 1 real solution. Okay, so now what I want you to do is go ahead and try this example out. Solve the system by substitution. Pause the video, and when you come back, I'll have the answer for you. Okay, so I hope you tried this out. Remember, because we have y equals and y equals, we can go ahead and make the equations equal to each other. So x squared plus 5x minus 4 equals 3x minus 1. Then you set it equal to 0. Then once you do that, you see that it is factorable. So it factors to x plus 3 times x minus 1, or x equals negative 3, x equals 1. Now, whenever you find this x value, you are not done. You have to find the y value, so you have to plug it back in to the original. And so I plugged it into equation 2. Again, whichever one is the most simplest to do, that's the one that I choose. So I plugged in negative 3 into equation 2, and when I did that, I got negative 10. So one of my answers is negative 3, negative 10. And then when I plugged in 1, when x is 1, my y value was positive 2. So these are my answers to solving the system. That means if I were to graph these two equations, they would intersect, the parabola and the line would intersect at these 2 points. Okay, so, just to get a visual on that, they would intersect at negative 3, negative 10, and at 1, 2. That's what this means. I hope this helps you out, and you'll get some more practice in class. Thanks for watching.